Today we're going to be looking at how I'm going about pitch bending on the EVI. This is all in the name of adding some juicy dynamics to the otherwise robotic sounds that synthesizers often make. Note that pitch bend is not exactly the same as vibrato, which I'll be covering in an upcoming video. To put it simply, the vibrato system on the EVI will be for wibbling the pitch just a little up and down, maybe modulating the amplitude, which is technically called tremolo, not vibrato, but that's really beside the point for this. On the other hand, the pitch bend system will be for bigger, wackier bending. Think electronic whammy bar rather than the gentle finger wobbling that you might see on a violin. Here's a sample of what I'm thinking. Originally I was planning to go with using a PlayStation 2 Joystick for implementing the pitch bend system, so there would be a nice tactile feedback when ripping a fat bend. PS2 sticks are basically just two variable resistors, one for each axis of rotation, so I thought that I would be good to go with them. Unfortunately, while they are fundamentally what I thought they were, they're not linear. What I mean by this is that there isn't a one-to-one mapping between the angle of the stick and the resistance of the potentiometers. This is alright for use as a gaming joystick because you don't want to be flicking the stick wildly around. You want it mostly around the centre position so you can quickly turn your character or aim your gun, etc. You can see what I mean on my ohm meter here. The resistance changes mostly around the centre position and then essentially clamps to its maximum or minimum value when you get past about 10 or so degrees of deflection. As boring as it may seem, I ended up getting around this by opting for the method that the EVI made by Akai and the new EVI by Bergland Instruments use. They use capacitive sensing to detect how much you're pressing the pitch bend pads. This is good because there are fewer moving parts to break, but on the other hand there's not so much in the way of tactile feedback to judge how far to push when bending a note. Here I've got a strip of aluminium foil under a sheet of plastic, and you can see on my serial monitor that the capacitance of the strip is varying depending on how much I squash my finger onto the foil. On my EVI I'm making it look a little bit nicer by using some cute copper pads. These are just little bits of unfolded copper pipe with some wires soldered on the back. I think they look nice, but a friend of mine thinks they look like used chewing gum after they've oxidized a bit. The copper pads have been mounted on little sliding rails so you can adjust the spacing between them in case you're an extra large engineer like me and consequently have stonking big extra large thumbs. You might have noticed there's some masking tape covering the copper pads at the moment. This is because the pads are actually a little too sensitive the way they are. To offset that, I'm covering them with a thin layer to isolate them electrically from my thumb. Masking tape is just for the prototype, and I'll likely replace it with some thin plastic sheet or perhaps a thick layer of varnish. If there's still an issue after that, I'm planning to do some configuration on the software side of things to tweak it to where it works like I want it to. In the end, that configuration will be accessible via the buttons and screen on the back panel of the EVI. The code for this demo is pretty simple. It just uses the Teensy's touch read function to measure the capacitance of the two bend pad and uses these to adjust the pitch created by the tone function. I'm doing a little bit of primary school maths to add a scaled version of the up value and subtract a scaled version of the down value so that fully pressing a pad shifts the pitch by roughly 1 octave either direction. In physical terms, a jump of 1 octave is a doubling or halving of the frequency. I aimed for a start note of 600 Hz, so 1 octave up is 1200 Hz, and 1 down is 300. In my code I've used an offset of 410, and this was just found by trial and error, and accounted for the up and down pads having slightly different capacitances even when I wasn't touching them. The serial print stuff at the bottom is just debugging info, so I could tweak the scaling and offsets. I'm going to see if I can demonstrate this. You can see just down here that I'm starting at roughly 600 Hz. So bear in mind that we're aiming for 300 in the down direction and 1200 in the up direction. If I bend the pitch down a bit, a little bit more, there we go, there, about there. Back up to normal, down, up, ooh god. A little bit higher. You get the idea. Apologies for screeching in your ears for a little bit there. It's really just a temporary thing because of the way I'm producing the notes. I'm using the tone function on the Teensy, which just spits out a square wave with no filtering. The lowly op-amp is also making an appearance here, to take that weak signal from the Teensy and give it a bit more grunt to drive a small speaker. Originally I had a piezo buzzer in there, but I think I was going deaf while testing it, so I took the executive decision to switch to something a little bit more mellow. While playing around with this setup, I had a look at the way the touch read function works on the Teensy, and thought it was pretty neat, so I'm planning to share that with you in an upcoming video. That's all for today though, so I hope you enjoyed listening to the Teensy screaming its little heart out. As always, remember to leave a like and a comment, and tap the subscribe button if you think you'd like to see some more in the future. Stay chill, and see you in the next one.